Hello people. So in this tutorial we will discuss more about machine learning and different ways in which we can do supervised and unsupervised learning. Okay. So this is just to give you the basic idea of all these methods. So in this video we will basically discuss about the linear regression and the logistic regression and under which category these two comes. And if you want a in-depth knowledge of how to run this on Python programming, then there are videos available on the data mock. You can just go and check the playlist or just type linear regression in Python data mock and you will be able to see our videos. Okay, so without wasting time, let's get to the video. So machine learning, as we all learned in the previous video, that machine learning is basically classified into three categories: supervised learning, unsupervised learning, and reinforcement learning. So what happens in supervised learning? There is a supervisor who trains the data set, who gives a training data set and trains the model, and then the model will work for all the other samples. And then we have something called the unsupervised learning, in which there is no training provided. So the algorithm, it'll or the program will basically observe, and based on observations it gives out the desired output. And what happens in reinforcement learning is that trial and error. Okay, so what happens in the trial and error method is that basically, suppose that if we touch something hot, then after that we will not touch it because we know that it is hot and it will cause pain. So similarly, what happens in the trial and error method is that the machine also does something, and when we say that no, this shouldn't be done, when we say that no, this shouldn't happen, then what happens is the machine then again from the next part it stops doing it. So basically it runs on the method of trial and error. Okay, so over here in this diagram what we can see is supervised learning develops predictive model based on both input and output data. So the very two important process in supervised learning is classification and regression. Okay, so classification again has many different methods. Okay, and then there is something known as unsupervised learning, as we all discussed right now. So the very prominent method in unsupervised learning, the most important algorithm is clustering. Okay, K means clustering. So moving on, if we move further, we see that examples of classification. So to make you understand what is classification better, we have taken three examples. One is speech recognition. Okay, so there is speech recognition. Suppose that let's say that Alexa, which we have, okay, or mobile phones in iPhones we have Siri. Okay, so all these AI robots, so it recognizes a speech. So this is an example of classification. It can say that whether they can tell us that whether our sound or our voice is different from other people. Okay, then face detection in our mobile. When we want to switch on our mobile, in many mobile there's a system of face detection that until and unless you don't show your face, your phone will not it will not you cannot open it. So face detection and handwriting recognition. Okay, which is also used in many cases, in court cases, criminal cases, handwriting recognition. So what happens is, and the major important example which we see in our day to day life is emails. When we open our emails, so there is one primary inbox and then there is a folder of spam. So our email automatically classifies whether that message is should come to the spam category or it should come to the inbox. So based on that, it basically separates them and keeps them in two folders. That is a classic example of classification. Then moving on, we have regression. So what is a regression? Regression is basically that based on the training data, our model will predict the future values. Okay, so age calculator, salary calculator, grade calculator. In the previous video we also discussed about housing prices, that based on a few training data sets which we provide to our model will predict the price of the house of if we provide the other data, it will predict the accurate price of the house, what the price of the house should be. And regression problem gives us the exact value. Okay, so moving on, basic structure of every algorithm is reading the data set and dividing it into training and testing data. Okay, so suppose that we have a sample of 1000. Okay, so there are the data samples number is 1000. So it will take suppose from 1000 it will take 100 as the training data and the rest 900 will come into the testing data. Okay, so there is a proper way in which the computer or the algorithm divides. We'll discuss about all those ways later in the later videos. Then it will train itself over the trained data set. Okay, the test the data or the test data set, and then it will find the probability and then deploy the ML algorithm in AI model and test it one. Okay, so what is machine learning? As we are discussing about machine learning, there's a very important diagram which we will discuss over here, that machine learning, it has supervised, unsupervised reinforcement. Okay, so in supervised, as we all saw, that we have classification and then we have regression. Okay, so classification is used in fraud detection, okay, image classification, customer retention, diagnostics. Then in regression we have forecasting. So as a data scientist, forecasting is very important. Okay, future forecasting about different things based on the past data. Okay, so these are few problems which you will encounter on a daily basis. Then predictions, then process optimization, new insights. So all these things, if we want to find out, we'll have to use regression. Okay, then in unsupervised learning we have dimensionally reduction, we have feature elicitation, we have structure discovery, meaningful compression, big data visualization. Then in clustering, we have customer segmentation, targeted marketing, recommended systems. Okay. Then in reinforcement learning, we have real time decisions, game AI, learning tasks, skill acquisition, robot navigation. Okay. So these are few things, these are in fact many things which we can, which if we have to do, we'll have to use these methods of machine learning, or we have to learn these algorithms of machine learning. Okay, now coming list of common machine learning algorithms. Okay, so don't get confused by all this different means. What is regression, what is linear regression, what is logistic regression. Okay, everything has a purpose. Every algorithm which is there for machine learning, it has a definitive purpose. Okay, so here is the list of commonly used machine learning algorithms. These algorithms can be applied to almost any data problem. Okay, so the very first is that we have linear regression. Okay, so linear regression comes in the category of what? Linear regression, it comes in the category of regression. Okay, it is a regression, but logistic regression, it is not a regression. So you shouldn't, get confused by the name that logistic regression. No, logistic regression is not a regression, it is classification. And why it is a classification method and it is not a regression method, we'll discuss later. Okay, so to tell you in brief is that logistic regression works on binary values. Okay, it works on binary values, we'll discuss about it later. So logistic regression basically comes in the category of classification and not regression, whereas linear regression is pure regression. Then we have decision tree. So decision tree again is a part of regression. Okay, decision tree is again a part of regression. Then we have SVM, naive Bayes, KNN, K means clustering, random forest, dimensionality reduction algorithms, etc. And we also have gradient boosting algorithms. So inside gradient boosting algorithms, we have GBM, XGBoost, Light GBM, Cat Boost, etc. Okay, so we'll discuss about the most important. So in this video, our purpose is to discuss about linear regression and logistic regression. Okay, so yes. What is linear regression? Okay, we often hear about linear regression, about how house prices prediction or about prediction forecasting, but you don't actually know that what actually it is and how it works. Okay, until you have studied this in your statistics class, because in statistics we learn about regression. So what is linear regression? See, it is used to estimate real values, for example cost of houses, number of calls, total sales, etc., based on continuous variables. Here we have established relationship between independent and dependent variables by fitting a best line. The best fit line is known as the regression line and represented by a linear equation y is equal to a into x plus b. Okay, then what is this y? What is this b? What is this a? So the y over here is the dependent variable. Okay, the y is the dependent variable for, let's say that in our house pricing example, the y is the price of the house. Okay, the y is the price of the house which we have to find. All right, then a is the slope. A is the slope and x is the independent variable. X is the variable which we give to the, which we input in the system, for example, let's say in the housing example, number of square feet of the house. Okay, the features of the house, whether the house is on the main road or in the interiors, all these things we just put a numerical value. Okay, we put a numerical value for all these things, and then we used to run a regression model. Okay, then B is the intercept. Okay, B is the intercept. So the best way to understand linear regression is to relive this experience of childhood. Let's say that you asked a child in 5th grade to arrange his class by increasing order of weight. Okay, without asking them their weights, what do you think the child will do? So let's say that, yeah, there is a class 5 child, and you tell them to, without knowing any other thing, just you tell them to arrange all the people or group all the people in the increasing order of their weight. So what will the child do? Generally, the child will look at those other kids. He'll look at the weight of other kids or his physique. Okay, if somebody is a little healthy, he'll put it in a higher weight category. If somebody is thin and the height is less, he'll put it in a less weight category. Okay, so basically he will see two things: the buildup of a student and the height of a student. Okay, and then according to that he will try to find out the weight. So this weight thing which he is trying to find out becomes our dependent variable. And what is this dependent variable depending on? It is depending on the height of the student and the buildup of the student. So these two becomes your independent variable. Okay, so in this video we're talking about linear regression. We are only taking one variable into consideration, but in when we do multivariable regression, we take more than one variables. Okay, so all right. So y is the dependent variable, a is the slope, x is the independent variable, b is the intercept. Then these coefficients a and b are derived based on minimizing the sum of squared difference of distance between data points and the regression line. So let's look at this example below. Okay, here we have identified the best fit line linear equation. So the equation for this line is y is equal to 0.2811x plus 13.9. Okay. So if this equation is plotted over here based on the height and the weight example which we just saw, we'll see that we have the height over here in centimeters and we have the weight over here in kgs. And the height is increasing as the height is increasing, the weight is also increasing. Okay, as the height is increasing, the weight is also increasing. There's a positive correlation between the height and weight. Okay, where weight is the dependent variable and height is the independent variable. Okay, all right, so this is a relation between height and weight. Now, linear regression is mainly of two types. Okay, it is mainly of two types. One is the simple linear regression, and then we have multilinear regression, as we discussed. So, in multilinear regression, what happens is there are two independent variables and one dependent variable. So, simple linear regression is categorized by one independent variable, and multilinear regression, as the name suggests, it is categorized by multiple or more than one independent variables, as I said. While finding the best fit line, we can fit a polynomial or a curvilinear regression, and these are known as polynomial or curvilinear regression. So this is the basic zest of what a linear regression model is. Okay. Now moving on, we have something known as a logistic regression. And as I said, that logistic regression is not a part of regression, it is a part of classification. Okay, then why is it called regression? Okay, so here I've written that don't get confused by its name. It is classification and not regression algorithm. It is used to estimate discrete values. Okay, binary values like 0 and 1 or yes or no or true or false. Binary values, the values which can have only two answers, either yes, no, 0, 1, like that, and based on given set of independent variables. In simple words, it predicts the probability of occurrence of an event by fitting data to logit function. Here it is also known as a logit regression. Logistic regression is also known as a logit regression. Since it predicts the probability, its output lies between 0 and 1. Okay, so again, let us try to understand this through an example. So let's say that our friend gives us a puzzle to solve. Okay, let's say that our friend, he gives us a puzzle to solve. Now there are only two outcome in this scenarios: either I solve the puzzle or I won't solve it. Okay, now imagine that you are being given a wide range of puzzles or quizzes in an attempt to understand which subjects you are good at. Okay, the outcome to this study would be something like this: if you are given a trigonometry based 10th grade problem, you are 70% likely to solve it. On the other hand, if it is a fifth grade history question, the probability of getting an answer is only 30%. This is what a logistic regression provides you. Okay. So now moving on. Okay. So coming to the math, the log odds of the outcome is modeled as a linear combination of the predictor variables. Okay. So in this, see this notation over here and above, P is the probability of the presence of the characteristic of interest. What is P? P is the probability of the presence of characteristic of interest, probability of event occurrence or probability of not occurrence. It chooses parameters that maximize the likelihood of observing the sample values rather than that minimize the sum of squared errors, okay, in ordinary, like in ordinary regression. Now you may ask why log. For the sake of simplicity, let's just say that this is the best mathematical way to replicate a step function. Okay, so now this is what a logistic regression is, and this is what the curve of logistic regression looks like. Okay, here in the x-axis we have x, and in the y-axis we have the probability of y is equal to 1. Okay, so this video was to just give you or introduce you to different ways of different algorithms. What is regression? What is classification? What is linear regression? What is logistic regression? In the upcoming videos, I'll be discussing or I'll be briefing you about different other ways, different other algorithms. Okay, and then after watching those videos, you can actually go to the use of those regression and regression models and other algorithms, and you can see that how you can use it on Python, how you can code it on Python. Okay, so if you want to check those videos out, you can check it. It is available on our playlist in the data monk. And yes, we'll meet again in the next video.